Hello, I'm Nachiket here from Access Solutions.
Hello, this is Deepak Padgaonkar from V3IT.
Great to have you all together today on this very interesting topic of Industry 4.0 and specifically the role of artificial intelligence in Industry 4.0. Uh, we'll like to have some of our own insights as well as our own experiences to be shared with all of you, where jointly we could build better solutions and bring the perspectives from different markets together.
That's great to have you, Nachiket, and let's explore some of the Industry 4.0 aspects, having kind of worked with manufacturing companies for over 30 years now. Um, some of the challenges therein are addressed by Industry 4.0 and moreover the new AI revolution therein. And I think it will be beneficial for the audience here to know what we are seeing in the industry today and what are the things that are taking it to the true Industry 4.0 revolution.
Certainly. So when we look at Industry 4.0, it's sort of a fourth revolution that we are referring to here. And this is entirely about a digital revolution that we are witnessing. And in all of our lives, we are seeing a drastic change of these new technologies that are bringing it. And certainly the industrial applications of them are also going to make a sea change, I believe, in very recent future that we look forward for.
Absolutely, couldn't agree more. I mean, there is so many things that are going on in the industry today. I mean, there is these human machine interaction, also kind of termed as cyber physical systems, the Internet of Things or sensors that have been collecting the data. There is this whole big data revolution. We have a lot of data in all of the customer systems, and artificial intelligence is just the natural next step to tapping into all this data that we have and going a step beyond automation. What I term is artificial intelligence is nothing but the next generation of automation, or what I also term as hyper automation.
That's correct. So what we have seen is that each of these industry revolutions have triggered because of one or other element making a sea change. Like the first revolution is where mechanical aspects came into the picture, where mass production was envisaged and thought through, which had a sort of a steam engine kind of a era, followed by motor electric engines coming in picture. Uh, then came in the mass production through the assembly line kind of interfaces. The third one came in a big way where we have started using electronics as well as computation on a very significant level, where we have a CNC machines and automation, robotics being introduced on a big scale. As you correctly pointed out, now is the era where we are going digital. Connected digital world is what we are looking at. And so at this phase, I believe that the major change is coming because of the compute power. The compute power that was available a couple of years back and what we have, availability as well as cost of compute, they have undergone a sea change. And when we look at uh, all of the industry leaders, including Gartner, McKinsey, uh, BCG Group, this part of the revolution is going to be purely driven because of the wonders that could be created with a huge data getting generated at the same time, most importantly, being able to get computed for a meaningful usage. And the actual application of that, which were taking a lot of time as well as cost, Both of them have drastically uh, dropped down in terms of cost is reducing at an exponential level in a downward direction, as well as the computational power is getting accessible, available at a in an inverse direction. So both of that, the new GPUs coming in, the new models coming in, is bringing a lot of interesting use cases all around us. So I
That's
believe that uh, the the amalgamation of all of these technologies and the resultant output is what we have started seeing, and soon there will be an explosion of such use cases.
Absolutely, could not agree more. That's so true. And the whole thing started with, yeah, the computer itself taking on. I mean, earlier, I can't believe that just a few years back we were talking about mainframes, and then we were talking about supercomputers, RISC-based computing, and slowly, fast forward 20 years later, we are seeing now in-memory computing. So no longer magnetic disks are holding data, it's all in memory, and it's very, very, very fast. And the advent of cloud itself has made compute power super accessible at a very economic means. And to get something to the next generation computing, such as quantum computing, is also becoming something that is amenable to almost every common man today through the era of cloud computing. And these things were not available uh, in years gone by. And this is really driving that whole innovation cycle uh, to taking it to the next step of this hyper automation, as I call it. So there are things that um, people are trying with not just computing AI, but also what we term as physical AI. So this is the human and machine interaction at the next level, wherein human can do exception handling and machines do the norm. And artificial intelligence combined with physical AI, which is robotics, is actually taking the uh, onus of doing the norm, conducting the norm, and leaving exceptions or the thinking capabilities to human to drive the factories of the future. I mean, and this is happening today as we speak in 2025. This is happening today, and we are seeing a lot of examples of this taking shape and going further.
Yeah, uh, the other aspect is not only the cloud computing but also the edge computing coming in picture. So instead of even sending the data to the cloud, it is now possible with the same computation being made available in this maybe at the same premise or within the data center of that particular organization. So it brings in the latency going down, cost as well as efficiency going up. These are some of the great advantages that are being uh, bought in because of the advent of these technologies. So when we are looking at a smart manufacturing, uh, some of the use cases prior I have witnessed where large scale manufacturing organizations, especially in Southeast Asia, they had been looking forward to deploy uh, IoT use cases as well as sort of automation use cases primarily. They had been doing so, they were getting challenges, especially because of gathering the large data across multiple devices and sensors, collecting them and sending them for processing, generating a meaningful outcome of that, and then doing a corrective action. So the whole process of this was taking a significant time and was taking a lot of bringing in reducing the efficiency that could have been possible. But now with the progress of edge computing, also the new GPUs and new processors that have come up, Just to give context, the recently launched NVIDIA GTX Spark. It's a small device which can, it is could just easily go in any backpack. Has a tremendous capacity for processing and could run LLMs on that case with a simple small device, which brings in a huge, opens a entire new avenue for innovation as well as new initiatives.
Yeah, and in fact, glad that you mentioned GTX. One of our partners, Google, has actually come up with a concept called TPU, Tensor Processing Units. So that is a layer of abstraction over and above CPU and GPU that actually has artificial intelligence processing units as computing units now, and that can be logically addressed as well as arrived at to do some very complex calculations, such as, for example, the things that fascinated me is generative design. I mean, generative design is something that is now designing something that is completely out of the norm. Earlier, in manufacturing, we used to use things like AutoCAD or many of the CAD CAM software to design and optimize existing design based on certain parameters. Now, you just tell the generative design process to actually generate a design out of thin air, giving no parameters whatsoever, and then it comes out with something that suffices that use case, and then you can parameterize it further within a matter of seconds. I mean, that's simply combining the use of 3D technology, using smart printing to actually get that objectified as a usable design beyond just the means of having it just a theoretical design put on paper, right? So that is something that has been put to use in some industries as a proof of concept for doing some things like optimizing aircraft parts and taking in queue materials or composites that did not exist before and can be strength relevant as well as weight relevant, because you're decreasing the weight and increasing the strength at the same time. So these are the kind of design parameters that engineers could have only thought of finite parameters before. Now these are like millions and billions of parameters that can be put into this generative design to come up with a conceptual design and put it to fruition at the same time. So that's super exciting, and the use case of the TPU was absolutely fascinating.
Certainly, I am believing that the creativity will have a new avatar now, because when there is a equally competent tool that you have in your hand, the the new avenues will open up with no bounds. Similarly, some of the traditional aspects have been major pain points of the industrial applications, especially for manufacturing, had been in terms of maintenance, quality control, and supply chain management, also productivity management. So these have been the traditional pain points or a major focus area for any industrial applications. Looking with the AI advent coming in picture, we are seeing that all of these are being very effectively thought through right from the basic approach. So it's very interesting how different uh, industrial applications are going a sea change. Just to give you one example, one of the large industrial manufacturers, especially metal components manufacturer, has started using on assembly line inspection tools which are AI powered, based on a vision computing. So just while the parts are on conveyor belt, they are being checked for the defects, any anomalies, and being alerted where they get graded, whether they could be remachined or they need to be junked or scrapped. So it's really going through one entirely in that manner.
Yeah, and that's so important, that quality control and visual inspection by a human was in a sense constrained and was very subjective. Now, with the advent of the vision control, or computer vision as we call it, they can measure defects, quantize it, and consistently deliver the same result one after another. And this not just in industrial manufacturing, they are used in automotive manufacturing. In fact, there was a interesting use case of satellite manufacture and satellite solar cell manufacture that I just recently saw, that those solar cells are literally micron or angstrom thick. And those cell detections is humanly impossible. But quality control using this computer vision is kind of taking shape and consistently preventing any quality loss. Because once these equipments, for example, go in space, there is no way of correcting this. So identifying the defects, taking measures to kind of control the quality and giving that consistent, efficient quality is so material. I mean, so important when it goes in space applications, for example. So, I mean, this is just innumerous examples of those same quality things. And then you're talking about supply chain optimization. I mean, it's very widely known that Amazon is probably the leader in supply chain optimization. You order a thing, and within hours or minutes, it actually arrives at the door. I mean, how efficient can supply chain optimization be? And that goes to the advent of this logical as well as physical AI coming into your doorstep. And this is something that we inadvertently use it day in and day out without even realizing that AI is now a very significant part of our life.
That's true. That's true. Even some of the products that we are working on, we are looking forward to bring in a quality management system of a next era, where even the standard operating procedures as well as quality management compliance requirements could be generated or populated based on the specific needs of that particular industry, using artificial intelligence, so which has wings brings in opens up multiple avenues again for adaptivity, ease, uh, being able to keep on with the pace of the change that happen even in the compliance and quality management systems, also being able to keep on top of the what is happening within your organization. So yeah, it's exciting, and we're glad to be able to contribute something meaningful in that. Also, some one of the interesting cases that we have recently are looking forward to work on is about the critical components being their warranty management, as well as trying to figure out how we can predict the outage or uh, replacement for specific parts. So with the data which was lying there for years together, we are now able to identify and sort of predict which are the components which might undergo wear and tear, and what would be the possible cost of such replacement, and how we can optimize that cost, managing the entire inventory life cycles for the customers. So this is opening a totally new avenue and dimension to the whole business, where we can think in a totally new way for the same old problem that we had.
Yeah, I mean, talking about predictive maintenance and preventing all these issues that were coming in, they are phenomenal.
Certainly. And another aspect that is going to certainly impact is the softer side, where the costs as well as optimization can happen, because you are able to uh, better deal with multiple scenarios, uh, be prepared for the multiple scenarios using the tech, and be more agile, so that you are able to have your price points as well as have your costing structures geared for multiple contingency plans. So finally, that's also going to add some of the crucial impacts in terms of industrial applications, where the supply lines have now been global, and we have seen in last few years, especially with the fluctuating international geopolitical scenarios, uh, the advent of pandemic and uh, regional conflicts, the effect of supply chain and the cost changes had been very dramatic. Now, uh, with tech, we are. I'm sure there multiple scenario planning is another thing that is being undertaken for dealing with the cost and uh, value changes accordingly.
No, interesting you mentioned that because the pandemic changed quite a lot of things, and this process of Industry 4.0 and AI adoption was actually increased significantly as a result. Now, one of the things that I can talk about is our partner LG, who used robotics during the pandemic to actually uh, account for some of the uh, human absence. Now, uh, fast forward to post pandemic, humans and machines are actually collaboratively working now to increase the efficiency way beyond norm, and they're called cobots, complementary robots which work with human. uh, Interesting part of that is basically they are now uh, taking this robot technology or cobot technology that they use out of the factory, and they're actually using this to help others implement the same technology in other manufacturing industries also. So LG has been very generous in opening up this technology, making it even open source to actually help
So,
other customers of ours actually take benefit of that technology, that experience, and quickly adapt to using these cobots in their manufacturing processes also. In fact, I was told that Tesla gigafactories are actually using a lot of these cobots to expedite the whole uh, generation of all those automobiles at scale, and that's phenomenal.
yeah, yeah. Certainly, we are coming into the era of dark factories, what we are now they are being known as, where you don't need a light because the humans are not working. It's completely the taken over by the robots. I personally believe it will take some time to reach to those stages where the entire factories would be taken over by the completely by the robots. But certainly, the era has become for the cobots, no doubt about that. While we deal with these changes, there are some significant challenges that we all see, right? Where we, with the new uh, tech coming in picture, there are concerns, there are challenges that are coming in. Primarily with the collaborations that have come up. They are in you just can't do without collaboration. And uh, all of us are thriving on the data. So this particular part of data privacy and security is going to be extremely important, and it's going to shape definitely the future of how these secure ecosystems are going to get created and nurtured further.
Yeah, absolutely. And there's so many other things that I can talk about, like in the AI transformation, the human element is a critical consideration. I mean, one of the things that we were talking about is scheduling software, as simple as scheduling software and automating it using some of the newer technologies, or using some of the older technologies, like simple technologies like CPM PERT, and using that to doing planning without the consideration of human elements is throwing the AI technology off, because human preferences, human considerations have to be considered, because those go into factors such as discrimination, giving the scheduling to the most efficient worker, and ethical considerations are also important as we do this AI, because these have to be considered while doing this whole planning. It's not just about gaining efficiencies at scale, it is also having that human factor considered when doing it ethical AI, and making sure that that is one of the most important factors that is considered as we do AI. And a simple example of that that I encountered recently, as we talk about cobots, is the advent of what we term as virtual reality, now complemented into augmented reality. So earlier, virtual reality, and there is a lot of research being done by Meta, there is research done by IBM, and is being put to use in a lot of projects. And uh, augmented learning is nothing but reinforced learning. So through the use of machine learning, they are able to kind of concoct the new training and show it as a virtual training in a 3D effect using robots, or they are actually able to simulate the scenarios and give the digital twins a new effect of training them in actual 3D models, as opposed to just showing them on a 2D screen. So that augmented reality, or what we term as reinforcement learning, is helping even the bounds of training, and uh, making it as realistic, as pragmatic as possible, uh, through the use of that augmented reality. And digital twins are now becoming effective, because these 3D models, this smart printing or 3D printing put to use in real life scenarios, actually tells the human that, hey, this is how the process is performed. For example, new product development initiatives are taking advantage of that. Whenever a new product, it's hard to imagine how to kind of do the manufacturing of the product, how to do the kind of garnishment, for lack of a better term, of the product
Mhm.
to make it ready for use, and all those processes that go along with that, that is made very effective through use of AI in this augmented learning or reinforcement learning. And it's very fascinating to see digital twins now made used to in practical cases, and actually seeing a whole effective new product development initiative before even the product is taking concept.
Actually,
And that's very fascinating that we are seeing in the industry.
yeah, I was also very taken aback when I witnessed one of the cases recently. One of the leading automobile manufacturers, who has a global presence, comes from India, has used effectively the digital twin technology for launch of their new product. They have used it to create different versions. Uh, as you mentioned, they have, before even the product was launched in market, they were able to go ahead and take a feedback from the prospective customers. So they were able to go ahead and fine tune their product market offering uh, without actual vehicle being ready in a physical form. Also, they had gone ahead and they are using it to launch different variants of this depending upon the very niche customer preferences, and that's turning out to be a extremely successful proposition, because instead of launching too many models, they are now creating variants based on the preferences of customer in terms of colors, interiors, the combination of the features that the customer is wanting for, and the product variation being released in a sequential manner over a period is allowing them to have in sort of increase the lifespan of the actual model significantly, giving them a significant value add in terms of longevity of the same business backend to reap the benefits of the scale.
Yeah, so important. And what is also happening is, as a result of this whole process, something called as a process that is emerging out of this called generative adversarial networks and GANs. And this is used as a concept in manufacturing a lot. That goes from design prototyping all the way to synthetic data generation for testing, training, and application into these initiatives. So it's basically going into design prototyping into, let's say, hey, the shape was cylindrical before, now how will it matter if it is cubical? I'm just throwing up examples there. Shape, color, size, metrics, all of those things can be parameterized and can be visualized into a very high fidelity prototyping using those interactive design tools and actually making the tweaks as the design happens. In fact, earlier human is to design and then kind of get the feel of how the design will probably look like. And this was put on paper using some of the tools that we had at that time. Now, those designs are being presented and also given an alternative of, hey, what if you were to do it this way? Now, this is something that we could not even think of before. And these are what is known as conditional GANs. Now, these conditional GANs, when presented to the human, are actually taking new prototypes. So, what you thought of a product X turn out in the actual production to be a product Y. And that could be
Mhm.
significantly different from, because it's a better product, it's more efficient, it's more cost effective, and all those parameters put to use in the prototyping phase itself, and through a process called synthetic data generation. So when this is this, and we used to use those data in planning generation for demand and supply plans, but now this is being used in manufacturing itself to kind of come out with a prototype instead of a plan, and that prototype can be put to use into 3D printing to actually make the whole design process itself very intricately involved into uh, not just producing a new product, but also doing things like data augmentation for how will it act in certain conditions, or um, doing what we term as anomaly detection in certain conditions. How will the behavior happen, or going to even simulation of what we term as unseen scenarios, like, hey, how will it happen in certain conditions which we cannot even think of, like weather conditions or wind conditions. And it's like earlier in my engineering days, we used to study under normal pressure and temperature conditions. Now, those
NTP.
normal and pressure and temperature conditions never happen. This is in practical pressure and temperature conditions. How does this behave is something that can be envisaged before even the prototype takes place. And then domain adaptation. So if we were to use it in a particular domain, how will it kind of interact? Whereas in a different domain, let's say in a manufacturing environment, this is how it will behave. But then when you take it out into the warehouse or into the retail space, how those things will happen. These are also things that can be portrayed and uh, put to use through this process of GANs. And this is a very extensive process that is evolving through the use of TPUs to kind of come up with the whole. It's a change, it's a shift in how prototype designing used to occur before at all.
Yeah, it's quite interesting and exciting, certainly a lot. And from where we are, I believe there are two major parts, that emerge. One, how is going to be the human role in this adoption, and second, what will be the future look like. So the first part, I believe, is where human role is going to become more and more important rather than it becoming redundant. So some of the aspects that you touched upon, the ethical considerations, the sensitivity part that needs to be bought into the adoption of artificial intelligence, the way the data is being exposed to these texts and sort of guided further. Those frameworks we will have to invest more on and evolve it more, where they become more human friendly and more human oriented. Uh,
Now, that is so important that we have to make sure as we build these systems and we are continuously working with the customers on this is data governance, data privacy, data security. All of those aspects are beyond human consideration, and also legislation. The federal or governmental authorities need to step in and kind of have that legislation. So this is governed at that higher level as well, and laws are put in place so that the things are being used for the good of humankind. It's human involvement, not only human involvement, but this whole technology is for human. And this is something that we have gone in all the industry revolution, starting from the mechanizing step of Industry 1.0 uh, to the automation step of Industry 3.0, and now into the hyper automation phase of Industry 4.0. Every industrial revolution has come up with these considerations, whether it is ethical, whether it is involving human, whether it is going to throw human out of job. All these considerations are important to be deliberated, debated about, and legislation and governance has to take care of these things as we move forward into this AI-powered ecosystem era. And the workforce transformation also has to be there. I mean, there was a time 20 years back who would have thought about a smartphone, but that has happened. It is a daily part and parcel of our life, and these things are getting more and more prevalent with also things like wearables. Like I think even 5 years back, we would not have thought about wearables. These are becoming a norm. Everybody is wearing them. Everybody's measuring how much exercise they did, how much their heartbeat was, how much their even yesterday I was in a very interesting discussion of how to measure blood sugar at a continuous level. Continuous glucose monitoring is also becoming part of that. So this is all part of that industry 4.0, which is something that unknowingly or knowingly everybody is already using it. And now the ethical considerations, the legal considerations, the governance of data and security, and making it human centric is something that we all have to conscientiously do. And as we actually get into the future of AI in the smart manufacturing, we have to not just make sure that the trend and innovations continue at the pace that they have, which is extraordinary. But at the same time, we are making those human considerations a prime and important facet of everything that we do.
Certainly, and while this transition happens, it is extremely important for us who have a responsibility of being a facilitator. So we have, I believe, we have a knowingly, unknowingly a role of being the enabler in this ecosystem, where we are also wearing the responsibility of educating the customers, also helping them to adopt these technologies, generating them confidence about them. While we are making the inroads in these futuristic technologies, uh, there are always questions, there are queries, but we have a solid role there where we are looking at building those confidences and taking along our clients, customers in this journey, increasing their confidence about these techs. While we say this, I look at the uh, a future which was of that of a Star Wars, where things which were dreamed in our childhood being in reality in near future. So, from practical point of view, autonomous factories are going to be reality. We are looking at parts of the world where there is a population decline. So there is the inevitably there are going to be a significant adoption of these autonomous technologies uh, for for the efficiency and lack of manpower being available. While we see that, I believe to adopt this technology, there is going to be significant requirement of the manpower which is going to be tech enabled, who understand and who are able to deploy, maintain this technology.
Absolutely. Could not agree more. Again, this is so fascinating discussion, and I'm sure we could talk hours on this. But yes, this is the new norm. Industry 4.0 is being adopted very aggressively by the industry. At the same time, yes, absolutely, we have to, as enablers of this technology in the Industry 4.0 revolution, we have to be very conscientious about what we do, how we tell the customers, and kind of educate everybody in the ecosystem as we go along, uh, so that we collaboratively come up with a very, very useful technology that is kind of for the benefit of human as we go to the next frontier.
Great. That has been a really interesting discussion, Deepak. Thanks a lot. Thank you very much for giving me this opportunity.
Nachiket, thank you as always. It's been very educative and very informative. You have had different experiences. Thanks for sharing that, and thank you for uh, helping us put this to light. So, thank you very much, and have a wonderful day, everyone, wherever you are.
Yes, thank you, Deepak, once again. And yes, we look forward to bring in more interesting discussions in the future. And uh, goodbye from all of us. See you around soon.